Real quick, as we start, today's not going to be about area of a circle. It's going to be called what a sector is, which I'll get into in a second. But area of a circle, either we know it or we're looking somewhere for it, all right? Because that's something I went over at the beginning. We don't need to memorize that. Area of a circle. One, yep. How about we go 13? Pi r squared, yep. Pi times the radius squared. Here's our focus today. Area of what's called a sector. And here's a sector. You got two radii and an arc. Okay, is it a piece of pie or a piece of pizza? If you want to think of it that way, sure. All right, but that's what a sector is. Two radii and an arc that connect them. All right, two radii and an arc. Here's the area formula for a sector. And again, that's something you guys are going to be responsible for. That's nothing you can find on your formula sheet. But it is related to the circle formula. Here it is. Measure of the arc over 360. Yeah, this is something we did last unit, but measure of the arc over 360 multiplied by your area of a circle, pi r squared. And I just want to remind everybody, measure of the arc, that's the same as the central angle, right? So just a reminder from last unit, that's the same as central angle. Remember, they're always equal. And that's what we're working on today, is finding the area of a sector. All right, ready to roll? All right, let's do it. So basic one right here. What's the area of a circle? Radius of 8 and formed by a central angle that measures 60. I'm not expecting diagrams at all, but I just want to make sure we get a visual because this is our first time with the sector. So central angle, remember what a central angle is, right? The vertex is the center. There's 60 degrees. I got a radius of 8. And what's the area of this sector? Let's see. I used to be able to do this a ton. Can he do it? Nope. That's sad. Actually, I'm not even going to keep going. But we see what we're looking at here? Right here, the area of this sector. All right. Let's do this. Measure of the arc. Measure of my arc first so I can plug it into the formula. 5, measure of the arc. 60. It's equal to the central angle. 60 over 360 times pi, radius 8, squared. Before we start hitting buttons on the calculator, everyone look at your multiple choice. Every single one's in terms of pi, yeah. So make sure our answer is in terms of pi. Remember what terms of pi meant? 60 over 360 times 8 squared, and I'm putting the pi in my answer. I just looked at all the multiple choices and it was like, whoa, whoa, whoa. It's all in terms of pi, so I want my answer in terms of pi. So I'm going to calculate everything I can in my calculator. Hopefully it gives me a fraction back. If not, I'll convert it into a fraction. And in terms of pi, what do you have in your calculator? In terms of pi, what are we looking at? 13, Charlie?
32 pi.
Good work. 32 pi over 3. So there's the area of that sector right there. Measure over 360 times pi r squared. Questions? All right, let's have a little fun here with 4 kids from a math class. They think they know how to find the area of COB. First, everyone take a look. Area of sector COB. Make sure you know where that is on the diagram. COB, that sector. So we're looking for this bad boy right here, this area. All right, what's the area of this part of the circle? All right, how about we do this? Let's write period 1's formula, and then we'll compare it to Amy, Beth, Carl, and Big Dex and see how many we agree with and how many we don't agree with. First, here's period one's. What is the measure of the arc? That belongs to COB. I know it's pretty given there, but
108.
108 over 360 times pi r. Again, what's r stand for in this formula? 3? Radius. I know none are labeled, Spence, but can you just give me a radius? No. Just give me a radius. Name a radius on my diagram. That's what I'm asking for. There's 3 of them on there.
Oh, the name of the OB.
OB. All right. Yeah. So we could plug OB in there. Anybody else? What else could we plug in there? 6. OC. Yep. We could put OC there. And I think we could plug one more in there maybe. 8. AO. Yep. Squared. All right. So we could plug any of those in there. So there's period ones. Everyone ready? Let's go through each kid here and see if they belong in this upper level math class or we got to give them the boot. Amy. Ooh, she starts out with 3/10. Is that okay? We started out with 108 over 360, but she started out with 3/10. Is she okay doing that?
Yeah.
Nate, why?
Simplified version.
Hey, take a look on your calculator and mine too. 108 over 360. That's just 3/10. So that's fine. That's not incorrect. Times pi times BC squared. We got a problem with that? Look at your diagram. What's BC? 4? What's BC in that diagram? It's a chord, but I need a radius. Amy, embarrassing. Wrong. Embarrassing. Beth, maybe short for Bethany, Elizabeth. Am I missing something? Okay, good talk. Great. We always have this conversation. It's May 1st. 108 over 360. Good there. We're good. Pi. She good with OC for a radius square? Yeah, we were. You can stay, Beth. You belong. All right, you belong. Carl. Oh, I don't know what that would be short. Carlos. Anything I'm missing? Okay. 3 over 10. We already said that that's fine. That's just reduced. Times pi. Now, what's Carl doing there with the 1/2 AB? What's AB in this diagram? From last unit. 9, what's AB? And what happens when I cut a diameter in half? So that's okay. Right, everyone? I'm taking 8. If you take half of AB, a half a diameter, yeah. Carl, you can stay. Dex. That's got to be short for Dexter. Right? I don't know what else it would be short for. How does Dex look? 108 over 360 times pi. What's the problem here, though? What's he squaring? He's not squaring 1/2. That's what we did above with Carl. What's he squaring? He's just squaring the diameter, right? And then taking 1/2. That's embarrassing, Dex. Get your game up. So it looks like Beth and Carl going to be able to stay. Are we all right there? Why? All right. Oh, there it is. It's been a while, kids. It's been a while. All right, let's hurry this up. Okay, the area is 12 pi. The length is 6. What's angle AOC? All right, now this is a one where I'm not asking you for the area. I'm giving you the area, and I want another part of the formula. So let me just write the formula out again. Measure over 360 times pi r squared. All right, where's the 12 pi going? 2. Where's my 12 pi going? What's the 12 pi represent in this problem?
The radius or the
read the problem through. What's 12 pi?
Oh, it's the area.
It's the area, so it should go in for.
A.
All right, there we go. 12 pi. I'm looking for angle AOC, so the measure is going to be x now, because that's what I'm looking for. Over 360 times pi. What are you plugging in for r? 1, yep. 11. 6 squared. So are we okay on the substitution before I get to the solving? All right, right away, notice left side and right side, they both have pi's. Get rid of them because they're going to cancel out eventually, whether you divide them first or at the end of the problem. So they're going to cancel each other out. So now hopefully this is a little bit easier. 12 equals x over 360 times 36. All right, I want to hear from you now. What would your next move be? Because there's a couple moves we could make right now. Because we have to get rid of the 36 and the 360 eventually. What's your move next? Probably will be right. 6. Sure, we can multiply both sides by 360 to get rid of it. Multiply. We could have also divided by 36. All right, we could have also divided by 36. So that cancels. I'm left with 36x on one side. And on the other, what's that bad boy? 4,320. And I think it's safe that we know what's going on from here. And that's going to be 120 degrees. Questions? All right. And now I just want to, so everyone's good with the sector. That's all I'm really doing with the sector today. All right, let's start using multiple formulas in one diagram. So you guys see my diagram here. Find the area of the entire thing. Name the figure on top and on the bottom for me. So we're going to be doing the area of these two figures added together right now. Name the figure on top and on the bottom. 8, what do you got on top?
Trapezoid.
Trapezoid. How about on the bottom?
Semicircle.
It's good, thank you. A half circle, semicircle. So that's what I'm going to find the area of, the trapezoid plus the half circle. All right, formulas now. Formulas. Give me the trapezoid formula. If you got to look back, but it's not on the formula sheet. 7, trapezoid.
1/2 times height times base 1 plus base 2.
Good work. Plus half a circle. I don't want the full circle. Ready? Half. And now what was the area of a circle again from today? 11? Okay, so just make sure we put the half with it though. Don't put full pi r squared. All good? So you guys can help me substitute in now. Everything is given there too. 1/2. All right, here we go. Help me with the trapezoid. 5, trapezoid height. 4 times, what are the bases? 7 plus 10, good work. Plus 1/2 pi. All right, who's got the radius of that circle? Who's got the radius length? 11 radius, half a 10, 5. We're all good substituting? And now you guys are going to go to work now. It said round your answer to the nearest tenth of a foot. just to make sure we're good. When you're ready, nearest 10th. What are you looking at here? 2. Nearest 10th.
Oh, 73.3.
Got it. And if you guys are putting units, make sure they're squared, right? If you're putting units there, make sure they're squared. Questions? All right, last one. Oh, we missed fade too. Remember that fade. All right, we got a rhombus. Diagonals are 24 and 10. Find the area of this figure. All right, so we already know it's a rhombus plus what else is attached to that rhombus? So I'm going to do the area of a rhombus plus what else is attached to it. 4, describe what's attached to it. 3 semicircles, right? Or if I put it together, and everyone all right if I do 1 point, a full circle and a half, so 1.5 circles. All right, look back. Rhombus formula. Rhombus formula. 5, rhombus formula.
Diagonal 1, or 1/2 of diagonal 1 times diagonal 2.
Good. Plus, everyone keep the 1.5 there. Pi r squared for a circle. 1.5 pi r squared for the circle. All right, we got some work to do now. Somebody first start me off with the rhombus. What were the diagonal lengths again? 13 diagonal lengths.
24.
Good. So this is nice and easy. 1/2, 24, and 10. Here's where we're going to have to work. What is the radius of one of those semicircles? So first, right, so everyone see that segment there or any of the others? That's a diameter. If you can find that diameter, we'll cut it in half, and that's what I'll put in here. All right, anybody, diagonals of a rhombus. What do they do to each other? That's going to help me out maybe finding that side length. Diagonals of a rhombus. One big property, 4. Remember anything?
They form right angles.
Okay, there's this one piece I needed. That this is going to be a right angle. And what else do the diagonals do in a rhombus that's going to help me get that 24 and 10 a little smaller? What else do they do to each other here? 5? Perpendicular.
Applies to each other.
Okay, good. So everyone, this 24 became 12 and 12. This diagonal of 10 became 5 and 5. Everyone see how we're going to find the diameter now. What can I use to find the diameter? 9?
Oh,
Pythag, here we go. A squared plus B squared equals C squared. Can somebody plug in the 5 and 12 where they should go? 12, where should the 5 and 12 go?
12, A, and 5.
Yeah, either one, just as long as none of them are plugged in for C, because that's what we're looking for. So what is that diameter length when you get to it? 12 again? 13, good. But remember, hey, that was the diameter. We need pi r squared. So cut it in half. Everyone should be putting 6.5 in for the radius. Everyone's good for the substitution part. And everyone sees the directions. Leave your answer in terms of pi. I'm going to show you something here. This is why I left it in terms of pi for this particular one. What do we get there? Half of 12, 120. Rhombus had an area of 120. plus, remember, leave your answer in terms of pi. So in my calculator, I'm doing 6.5 squared and then multiplying that by 1.5. So I get 63.375 with the pi with it. Leave your answer in terms of pi, keep the pi there, and I have a question for you. Bless you. 63.75 pi. Do you think I could combine the 120 and the 63.75? Well, let me ask you this. Instead of pi, if that was an x there, or a y, or any variable, would you be able to combine the two? Nope. So you can't combine it here. This right here is your final answer in terms of pi. Okay, that's your final answer in terms of pi. Cannot combine them because the 120 does not have a pi. If the 120 had a pi, we'd be all right. Questions? So take a look at tonight's assignment. Part of it's in the packet. That's all your sector work is in the packet. And then you're going to go to page 801 in the textbook, and that's the combined problems we just worked on. All right, so let's get moving.